Picture this. It's 1962, and a privateer Corvette with what's essentially a truck engine just humiliated a field of Ferraris, Jaguars, and Porsches at Sebring. The European teams are stunned. Their highly strung exotic power plants with overhead cams and multiple carburetors just got beaten by an American pushrod V8 that started life-hauling lumber. This is the story of how Chevrolet's small block V8 became the most unlikely sports car killer of the 1960s. Here's what makes this even more incredible. While Ferrari was hand-assembling engines that cost more than most Americans' annual salary, and Jaguar was perfecting twin-cam straight sixes that required PhD-level maintenance, Chevrolet had accidentally created a racing weapon by solving a completely different problem. They needed a reliable, lightweight V8 for their new 1955 trucks and passenger cars. What they built instead was an engine that would dominate road racing for the next decade. The Chevrolet small block V8 wasn't supposed to be a sports car engine. It was supposed to be cheap, reliable, and easy to manufacture. But sometimes the best racing engines come from the most practical beginnings. To understand how a truck engine became a track weapon, we need to go back to 1954. Chevrolet was getting destroyed in the marketplace. Ford had their Y-block V8. Chrysler had their Hemi. Even little Studebaker had a V8. Chevrolet? They were still pushing their ancient Stovebolt 6 that traced its roots back to 1929. Ed Cole, Chevrolet's chief engineer, knew they needed a V8 yesterday. But here's where it gets interesting. Cole didn't want just any V8. He wanted one that was light, compact, and could be manufactured for less than the competition. The parameters he set seemed impossible. Under 550 pounds fully dressed, able to fit in the same space as their inline six, and cheap enough to put in every Chevrolet from the base model to the Corvette. The design team, led by Harry Barr and Ed Cole himself, came up with something revolutionary in its simplicity. They created an undersquare engine. The bore was smaller than the stroke. In 1955, when everyone else was chasing high RPM with oversquare designs, Chevrolet went the opposite direction. The original 265 cubic inch version had a 3.75-inch bore and a 3-inch stroke. This wasn't sexy, it wasn't exotic, but it was brilliant. Let me explain why undersquare mattered. An undersquare engine produces more torque at lower RPM. The longer stroke means the piston travels further, creating more leverage on the crankshaft. It's like using a longer wrench to loosen a bolt. Same force, more torque. While Ferrari's Colombo V12 needed to scream to 7,000 RPM to make power, the Chevy small block was pulling hard from 2,000 RPM. In road racing, where you're constantly accelerating out of corners, that low-end torque was worth more than peak horsepower. But the real genius was in the details. The small block used thin wall casting techniques that nobody else in America had mastered yet. The cylinder walls were just 0.25 inches thick, half what Ford and Chrysler were using. This saved 50 pounds right there. The intake manifold doubled as the lifter valley cover, saving more weight and parts. The stamped steel rocker arms were simple but effective. Everything about this engine was designed for mass production, which accidentally made it perfect for racing. Here's where things get really interesting. The small block weighed just 535 pounds, fully dressed. A Jaguar XK engine, 650 pounds. A Ferrari Colombo V12, over 700 pounds. That 100-plus pound difference was huge in a 2,400-pound sports car. It meant better weight distribution, superior handling, and less stress on brakes and tires during long races. The first hint of the small block's racing potential came in 1956. Chevrolet offered a special high-performance version called the Power Pack. It featured a dual 4-barrel carburetor setup, solid lifter cam, and higher compression pistons. This bumped power from the standard 162 horsepower to 240. But here's the kicker. This was still using the truck engine's basic architecture. Same block, same heads, same bottom end. Privateers quickly discovered they could buy this setup from their local Chevrolet dealer for about $500. Try getting racing parts from Ferrari for that price. By 1957, Chevrolet had bored the engine out to 283 cubic inches and achieved the magic 1 horsepower per cubic inch with fuel injection. The Rochester mechanical fuel injection system was finicky and complicated, but when it worked, it transformed the small block into something special. The engine could now rev to 6,500 RPM reliably, not bad for a pushrod design that started life in pickup trucks. But it was in the hands of privateers that the small block really proved itself. See, factory teams had unlimited budgets and exotic machinery. Privateers had to win with whatever they could afford, and what they could afford was a small block Chevy. The aftermarket exploded with performance parts. Edelbrock made intake manifolds. Iskandarian ground camshafts. Hooker built headers. Within 2 years of its introduction, you could build a 300 horsepower small block for less than $2,000. That same money might buy you a valve job on a Ferrari engine. The transformation was remarkable. A stock 283 with a 4-barrel carburetor made about 185 horsepower. Add a performance cam, $75, aftermarket intake manifold, $125, headers, $150, port and polish the heads, $200. Suddenly you had 275 horsepower from an engine that any competent mechanic could work on. No special tools, no factory training required. The pushrod valve train that seemed antiquated compared to overhead cams? It turned out to be an advantage. You could swap a cam in 2 hours. Try that with a dual overhead cam engine. The small block's finest hour came in SCCA production racing. The rules required using engines available to the public, which played right into Chevrolet's hands. While Ferrari and Porsche brought limited production specials that technically qualified, Chevrolet was racing engines you could buy at any dealership. The Corvette Grand Sports, despite being outnumbered and outspent, regularly beat factory teams from Europe. At Sebring in 1962, privateers running small block Corvettes finished 2nd, 6th, and 9th overall. They beat factory Ferraris, works Porsches, and official Jaguar entries. The European teams couldn't understand it. Their engines were more sophisticated, more expensive, more exotic in every way. But the small block had something they didn't: accessibility. When something broke, you could fix it in the pits with parts from a local auto store. When you needed more power, any speed shop in America had what you needed. Roger Penske's Xerox Special really showed what the small block could do. This was a Cooper Monaco chassis, basically a Formula One car scaled up for sports car racing, with a 327 cubic inch small block. The engine made 400 horsepower and weighed less than the Coventry Climax 4-cylinder it replaced. Penske dominated USRRC racing with it, beating purpose-built Lotus 19s and McLaren Elvas. A truck engine in a Formula car chassis, beating the best Europe had to offer. The weight distribution advantage can't be overstated. The small block was compact enough to sit entirely behind the front axle line in most chassis. This gave a weight distribution close to 50-50, sometimes even rear-biased, in mid-engine applications. The big block Cobras everyone remembers? They actually handled worse than small block versions because of the extra weight over the front wheels. Carroll Shelby himself preferred the 289 Cobras for road racing. Let's talk about that torque curve for a moment. A typical small block 327 made peak torque at 3,600 RPM. A Porsche 911's flat 6, 5,500 RPM. A Ferrari 250's V12, 5,000 RPM. This meant the Chevy was already pulling hard when the European engines were just waking up. Coming out of a slow corner, the small block car would gain 2 or 3 car lengths before the high-strung engines hit their power band. In a 12-hour endurance race, those little advantages added up. The reliability factor was huge. The small block's under-stressed design meant it could run flat out for hours without problems. The same characteristics that made it perfect for towing trailers, strong bottom end, conservative cam timing, efficient cooling, made it ideal for endurance racing. At the 1963 12 Hours of Sebring, small block Corvettes ran the entire race without engine problems. Meanwhile, the Ferrari team lost 2 cars to engine failures and a third to transmission problems trying to handle their engine's power. The aftermarket support became a phenomenon unto itself. By 1965, you could build a small block to any specification imaginable. Want a screaming 8,000 RPM road race engine? Crane cams had a roller cam for that. Need stump-pulling torque for hill climbs? Wayand made a tunnel ram intake that would double your torque curve. The Hot Rod magazine classified ads were filled with small block speed parts. It was an entire ecosystem that no other manufacturer could match. Here's something most people don't know. The small block's valve train, despite being pushrod operated, was incredibly efficient. The stamped steel rocker arms had a ratio of 1.5 to 1, meaning the valve opened 1.5 times further than the cam lobe height. This allowed for aggressive valve timing without excessive cam wear. The shaft-mounted rockers on European engines might have looked more sophisticated, but they weren't any more effective. And when a rocker arm failed on a small block, $5 and 5 minutes to replace. On a Ferrari, ship it back to Maranello. The cooling system was another accidental advantage. The small block's coolant passages were designed for the worst-case scenario, a loaded pickup truck climbing a mountain in summer. This overcapacity meant the engine ran cool even under racing conditions. European engines, designed for lighter duty cycles, often overheated during long races. The small block just kept chugging along at 180 degrees. By 1965, the small block had grown to 327 cubic inches in standard form, with some racing versions pushing 350. The L79 version made 350 horsepower with a single 4-barrel carburetor, more than many European engines made with multiple carbs and exotic valve trains. But here's the beautiful part. It still idled smoothly enough to drive to the track. Try that with a racing-cammed Ferrari engine. The cost difference was staggering. A complete small block rebuild cost about $800 in 1965. A Ferrari engine rebuild, $5,000 minimum, and that's if nothing exotic broke. This democratization of speed changed racing forever. Suddenly, a dentist from Ohio could build a car capable of running with factory teams. All he needed was a small block Chevy and the willingness to turn wrenches. The influence went beyond just Corvettes. The small block found its way into everything. Cobras, Lolas, McLarens, Chaparrals. If it was winning races in the 1960s, there was a good chance it had a small block Chevy. Jim Hall's Chaparral 2A, one of the most advanced race cars of its era, with ground effects and automatic transmission, used a small block. Why? Because it was light, powerful, and absolutely reliable. Even the engine's supposed weaknesses became strengths. The 2-bolt main caps that everyone criticized as inadequate, they worked fine up to 400 horsepower, which was more than enough for most racing classes, and when you needed more, aftermarket 4-bolt main caps were available. The cast-iron construction that seemed old-fashioned compared to aluminum, it meant the block could take incredible abuse without cracking. You could blow a head gasket, overheat catastrophically, and still salvage the block. The tuning flexibility was unmatched. The same basic engine could be configured for any type of racing. Short-track oval racing, high-compression pistons and a lumpy cam for maximum power between 4,000 and 7,000 RPM. Road racing, milder cam, lower compression, broader power band. Drag racing, tunnel ram intake, and stupid amounts of cam duration. No other engine platform offered this versatility. Let's talk specific victories. The 1963 SCCA A Production Championship, won by a small block Corvette. The 1964 USRRC Championship, small block-powered Chaparral, the 1965 Nassau Speed Week, dominated by small block Cobras and Corvettes. These weren't flukes. This was consistent, repeated success against supposedly superior machinery. The maintenance simplicity can't be overlooked. A privateer team could rebuild a small block in their garage with basic tools. Pistons, rings, bearings, gaskets, everything was available at the local auto parts store. Compare that to a European engine where every part was special order, every clearance required metric measurements, and half the fasteners were some bizarre thread pitch that required special tools. The small block even changed how race cars were designed. Engineers started designing chassis around the engine's compact dimensions and lightweight. The Lola T. Simity, one of the most successful sports racers of the era, was specifically designed for the small block Chevy. Eric Broadley knew that privateers would buy his cars if they could use affordable Chevrolet power instead of expensive European engines. By 1967, the small block had grown into the 302, 327, and 350 variants, but the basic architecture remained unchanged. That truck engine from 1955 was now winning international races, setting speed records, and forcing European manufacturers to completely rethink their approach. Porsche developed the 917 partly in response to getting beaten by small block-powered cars. Ferrari's sports car program shifted focus because they couldn't compete with the privateer's bang-for-buck advantage. The durability numbers were insane. A properly built small block could run 24 hours straight at 6,000 RPM. Try that with any European engine of the era. They'd need rebuilds after every race, sometimes after every session. The small block? Change the oil, check the valve lash, go racing again. This reliability meant privateers could actually afford to run a full season. They weren't spending all their money on rebuilds. Here's a detail that shows the engine's influence. By 1968, virtually every American road racing team had switched to small block power. Even teams that had been loyal to Ford or Chrysler made the switch. The reasons were simple: parts availability, tuning knowledge, and proven reliability. The small block had become the default choice not because of marketing or factory support, but because it worked. The story reaches its peak with the development of the Z28-302. This engine was built specifically to meet SCCA Trans Am Racing's 3/5 cubic inch limit. Chevrolet destroked the 327 to 302 cubic inches, creating a high-revving screamer that could pull to 7,000 RPM. With a single 4-barrel carb, it made 290 horsepower. But everyone knew that rating was conservative. Racing versions made close to 400. The Z28 dominated Trans Am Racing, winning the championship in 1968 and 1969. But here's the beautiful part. You could buy this engine in a Camaro at your local dealership. For $4,000, you got a street car with a genuine racing engine. No homologation specials, no limited production runs, just walk in, write a check, drive out with a race car. The European manufacturers never recovered from the small block shock. They'd spent decades developing sophisticated, expensive engines that could barely match what Chevrolet created by accident. Their overhead cams, multiple carburetors, and exotic materials meant nothing when a pushrod V8 with a single carb could match their power and reliability at a tenth of the cost. Think about the philosophical implications. The small block proved that accessibility beats exclusivity, that simplicity beats complexity, that practical engineering beats exotic solutions. It democratized performance in a way that changed motorsports forever. Before the small block, racing was for wealthy gentlemen or factory teams. After the small block, anyone with mechanical aptitude and modest means could go racing. The legacy is staggering. That same basic engine architecture went on to power everything from grocery-getter sedans to 200-pace supercars. It won at Le Mans, dominated NASCAR, conquered drag strips, and powered more hot rods than any other engine in history. Modern LS engines still use the same basic concept: pushrod-operated valves, compact dimensions, understressed components. The formula still works. But in the 1960s, when it was just a truck engine that happened to be good at racing, it represented something bigger. It was American pragmatism beating European sophistication. It was shade tree mechanics beating factory teams. It was proof that the best solution isn't always the most complex one. The small block didn't outsmart sports cars through sophisticated engineering or exotic technology. It outsmarted them by being exactly what it was: a simple, reliable, affordable engine that anyone could modify, maintain, and race. Sometimes the best racing engine isn't the one designed for racing. Sometimes it's the one designed to haul plywood on Monday and win races on Sunday. What's your take on the small block's dominance? Was it American ingenuity or just dumb luck that created the greatest racing engine of the 1960s? Drop a comment below, and don't forget to subscribe for more stories of unlikely engineering triumphs.